Okay, on this video we are going to go through some of the questions from the revision polynomial extension 1, and I'm going to be pausing the video to go to the next page, but yeah, I think that is going to be okay. Alright, question 1. In question 1 we have: consider the polynomial px equal to x to the power of 4 minus 3x squared plus 5. Part 1 is, it says, what is the leading coefficient of px? Is it a monoquartic? And then part 2 is, what is the degree of this polynomial? And the third part, what is the maximum number of real roots that we can have from this polynomial? Okay, so to answer the first question, I think that you shouldn't have any problem. Okay, so we know that the leading coefficient is equal to 2. Okay, so we're going to say leading coefficient is, the leading coefficient is always, the coefficient in front, the leading coefficient is always the coefficient in front of the leading term. In this case, the leading term is 2x to the power of 4, so therefore, well, the leading coefficient is simply 2. Okay, and then is it a monoquartic? Well, the answer is no, because you can see that the number in front of the x to the power of 4 is equal to 2, so that means that is not a monic. Okay, so we're going to say the answer for the second part of the first question is simply no. Okay. Okay, and then part 2, they say, what is the degree of this polynomial? Well, the degree is equal to 4. So we're going to say degree of this polynomial is equal to 4. And then the third question is to say, what is the maximum of real roots of this polynomial? Well, the answer from that question comes from the degree of this polynomial. Because the degree is 4, then the maximum of real roots that we can have is 4. Okay, so we're going to say the maximum number of real roots is equal to 4. That's it. Okay, for question 2, we're going to do a little bit of algebra, so you're going to have to be patient and see, all the steps. Okay, in this question, this is a very, common question in test. Okay, so in here we have a polynomial, and then we have to find the answer for A, B, C, and D. And because this polynomial is true for all value of x, so that means that in there actually we have an identity. And then what we are going to do, a little bit of manipulation of the right side, and then we are going to find, the answer for A, B, and C. Okay, the first thing that what I'm going to do, okay, so this is question 2. The first thing that I am going to do is to write that polynomial like this. So it's x cubed. You can see that the x squared term is missing, so you're going to put plus 0x squared, and then we have 3x, and also the constant is missing. Okay, and then we are going to equate that to that big expression. So we're going to have ax, and then x minus 1 is squared, and then we have b x multiplied by x minus 1, and then we have plus cx plus d. Okay, so I think that we're gonna need a little bit of ink for this question. Okay, so in question like this, what we are going to do, we are going to expand all this expression, and then we're gonna express the answer from here like this. So we're gonna have this structure. Okay, so before we do that, I just want to show you that the coefficient of x cubed in this polynomial is 1, and you can see that the coefficient of x squared is 0, and then you can see that the coefficient of x is 3, and the constant is equal to 0. Okay, so what we are going to do, as I said, we are going to expand and simplify this expression until we have something that we can match to the other side. All right, so in here we're going to have ax, and then this is equal to x squared minus 2x plus positive 1. And then the next part is going to be bx squared minus bx, and then we have plus cx plus d. Okay, so when you do the multiplication, when you do the expansion, you got to be extremely careful, because if you make one little mistake, then yeah, the whole thing collapse. Okay. Again, then we're going to continue with the expansion. So in here we're going to have ax cubed minus 2ax squared, and then we have plus ax. And then we have all the rest. So we're going to write it down again. Plus d. Okay, at this point we are going to collect like terms. Okay, and we can see that we have only 1x cubed. Okay, so we don't have any other term with x cubed, so we're going to just write it down. But then we can see that we have x squared here and we have x squared here. So that means that x squared is a factor of b minus 2a. So we're going to say b minus 2a. X squared. All right, so you can see x squared, and then we have b minus 2a. Okay, similarly we can see that x is a factor of c minus b. Okay, so x is a factor of c minus b. So we're going to write it down, c minus b in bracket, and then we have the x, and then plus d. Okay, so at this point you can see that we have a cubic, and we have this cubic in order. So we have the first term, which is x cubed, and then we have x squared, then we have x, and then we have d. All right, now is when we have to match the coefficients. So we can see that the coefficient of x cubed is equal to 1. And in here is equal to a, so that means that we can say that a is equal to 1. Okay, so we're going to say, so therefore we have that a is equal to 1. And then we're going to match the coefficient of x squared. And you can see that in here is 0. And because this is an identity, so the coefficient match. Okay, so then we're going to say that b minus 2a is equal to 0. And also we can say that c minus b, which is the coefficient of x, is equal to 3. Okay, so we can say that c minus b is equal to 3. And the easiest one is this one. Okay, so in here we're saying that, you know, the constant is equal to 0. So d is equal to 0. All right, so we got all this. Okay, and then we need to find the answer for b. Okay, so we can say that b is equal to 2a. And we already know the answer for a, so that means that, so therefore we can say that b is then equal to 2. Okay, so we got the answer for a. We got the answer for b. Also, we have the answer for d. And then we need to find the answer for c. Okay, from here we have that c is equal to 3 plus b. So it's going to be 3 plus b. And we know that b is equal to 2, so therefore c is going to be 3 plus 2, which is equal to 5. Okay. That's it. Okay, so that's all what you have to do for this question. And this, like I say, is a very, very common question in tests, okay, in which you're going to have an identity, you are going to find, you know, the answer for some polynomial, and this is how you do it. Okay, so you equate the given polynomial equal to the given expression, you manipulate it until you have the same structure as the given polynomial, and then you find the answer for the polynomial just by equating each corresponding coefficient. Okay, all right. Now we are going to do the next question, which is question 3 from part B. Okay, so I'm going to pause the video just to move the question up so you can see better, and then we'll continue.